Hi, welcome to Tag Arcade. And in today's tutorial, we'll be moving the enemy. So if this tutorial helps you out, go to my website, www.tagarcade.com, and click on this button on the top right-hand corner. So let's go ahead and create a script called Move Enemy. Next, we're going to drag Move Enemy to all of our three enemy types. So Enemy 1, Enemy 2, and finally, enemy 3. Now let's go ahead and click on each enemy to make sure we have move enemy on each of them. There we go. So the next thing we're going to do is we're going to move the enemy to the right first. So let's go ahead and open up the script. And I'm going to go to move enemy. And first we're going to create an enum. So public enum move, and we're going to say right. Oops. Come on. So next we're going to say public move direction. And right now, when we start the game, we want our direction to equal move dot right. Now, in the update function, we're going to say if direction equals move dot right, we're going to say this dot transform dot translate parentheses, speed times delta time, time dot delta time, comma, 0, comma, 0. And finally, we actually did not define our speed. So let's go public speed, public float speed. We'll say initially, we'll try 0.5 f. We'll see how that goes. Okay. So when you put a 0.5 over here, that means that by default, if you drag the script onto a game object, it'll always get the default speed of 0.5 f. You could definitely go into the editor and change that speed later on, but that's going to be your default speed. To show the point, let's go into our enemy, and if we go to our speed, our default speed is 0.5. Like I said, you could go in and change it to 1, but let's see what 0.5 looks like first. So we're going to say play, and yeah, these enemies are moving to the right at 0.5. That is really slow. Okay, so let's go ahead and change it. Let's see what a speed of 1 will do. Play. Yeah, it's still really slow. Let's say 3. You know, I probably should have did this on one enemy. There we go. That seems good. And they're actually going to keep on moving to the right and not stopping anywhere. Okay, so next thing we're going to do is we're going to create markers. So let's go ahead and create, let's say we'll use a cube. And we'll move this to position 0, 0, 0, and move it to the right. So about, I guess over here. So this will going to be called my right marker. And we're going to duplicate this and move it all the way to the left. And we'll call this our left marker. Once you do that, we're going to take off the box collider. We're going to take off our mesh renderer, so we're going to hide it. and we're going to do the same thing. Well, actually, since we're doing testing, let's go ahead and show our marker. But when we want to publish our game, we're going to definitely hide it. So let's go ahead and save our scene. And now let's go ahead and make a reference to those markers. So we're going to say private, transform, left marker, private, transform, right marker. And our right marker is going to equals to GameObject dot find and what did I call this? I call this right marker. Copy, paste, dot transform, and we're going to copy you, and we're going to say left marker equals GameObject.find left marker.transform. File save. Okay, so we're going to say if we're moving on the right direction, we're going to move to the right, and if this dot transform dot position is greater than our right marker. So we're actually going to look at the x position. So this dot transform dot position dot x is greater than our right marker dot position dot x. Then our direction should move to the left. So we're going to say comma left for our enum. And we're going to copy u, paste, and say move left. Dot left. File save. Of course, I have to say how I'm going to move left. So we're going to take all of this, copy, paste, and we're going to say -1 times speed if we're moving to the left position. And also I should probably copy you too, so that I could go left and right. So if this dot transform dot position at x is less than right marker dot, not right marker, left marker dot position at x, we could move back to the right. So what is going to essentially happen is that our enemy is going to start moving left and right. So let's go ahead and play, and pretty much I don't want to have to move the player to avoid being shot by the bullet, by the enemy fire, so I'm going to take off my sphere collider so that I'll be invincible temporarily. And let's just see if the enemies go left and right. Yep. So they are moving right, and when the enemies move to this position, they're going to go to the left. The only problem is they're sort of overlapping because right now they're, I guess, all moving right until they hit that position and move left. But the only thing about Space Invader is all the enemies sort of move it as like a unit. So they all move left at the same time, and they all move right at the same time. So wouldn't it be great if there was a way to have one instance and one instance only of the direction, so that when we change the direction to say right, all the enemies move to the right, and if we change the direction to left, all the enemies move to the left. So it turns out there is actually a word that we could use so that we could have one instance and one instance only of direction. And that turns out to be the word static. So when we talked about static classes and functions before, it was pretty much just one instance of a class and a function. But we could also apply that to variables. So we're going to say public static move direction. Okay, so we're going to make direction a static function. So that way that direction only has one instance and one instance only that will be shared across all of these enemy objects. So when we change direction, all of our enemies are going to change direction at once. So let's go ahead and hit play, and let's see that happen. So enemies are going to go there, to the right, it goes to the left, hits that marker, and it's going to go back to the right. Okay. The next thing we want to do is we want to move the enemy downwards. So the easiest way to do that is we're going to add two more directions to our enum. We're going to say down, then left, and then we're going to say down, then right. Next, we want to say how far we want to move down. So we'll say public float down distance. And we'll say 0.5 too. Why not? So what we're going to do is, once we get to our position, once we move all the way to the right, we actually don't want to move left. We actually want to move down, then left. And then instead of moving right, once we get all the way to the left, we want to move down, then right. Okay. Now what's going to happen is we're going to use an else statement. So if we're not moving left or right, we must be moving down. So we're going to say this dot transform dot translate it's going to be 0, 0, and then I'm going to say speed times time dot delta time. Right? And before I actually move down, I need to determine how far I move down. So I need to know about my start position, my start of the z position. So private float z start z position. Okay. So we're going to say start z position equals this dot transform dot position dot z. Okay. And we're going to copy u to here as well. And what we're going to say is if vector3 dot distance of my z position, my start of the z position, and how far I move down, so this dot transform dot position dot z is greater than our down distance then we're going to change direction. So if direction equals move dot down dot left, then we're going to move left. So direction equals move dot left. Else we must be moving down dot right. So we'll just say direction equals move dot right. Okay. And oops, forgot my semicolons at the end of right and left. So now this should take care of the enemies moving down and then left and down then right. So let's go ahead and watch this enemy movement take place. Oops. So what did I mess up? Can I convert expression float to a vector 3? Oh, so we're actually, that's why. We actually want to find a distance between the z position. So I use vector3.distance. We're actually not comparing vector threes. We're just comparing the distance. So it's just safe to say if, yeah, I think this should be fine. If start position minus this.transform.z position is greater than down distance, then I should be able to move down that left and move down that right. Okay, so let's make sure we do our subtraction correctly. So we're gonna use our player sphere, I guess. So right now let's just start at a positive number. So we're gonna have our z position. So let's say 6.5, and then we scroll down a little bit, and we're gonna do the subtraction. So yeah, it looks like our subtraction is correct. So I'm going to do Control Z for undo and hit save. And now let's watch this in motion. Okay. It goes right. Oh, it looks like they're going down in the Z position. It looks like I should have went down on my Y position. Okay, so let's go ahead and change our enemy. And we'll change this to 90 degrees. So file save, play. Yeah, so that's going into the down position. So let's go ahead and change the translation to my Y position. So let's hit cut, paste. And let's see if this moves in the correct direction. Okay, so that's moving backwards. So we're going to say -1 times speed to go forward. There you go. So it should start going right, then down, then left, then down. Yeah. So it went down a little bit. Goes to the right. And it just goes left and right. Oh. So it is going down a little bit. But it's actually not going down that far because 0.5 is a very small increment. So it goes to the left. Yeah. So instead of 0.5, let's just move it down a little bit more drastically. So we'll say 1. Okay. And when we hit play, there we go. So it goes down a little bit more. It looks like it didn't go down that time. It goes down here. Goes down. So let's just do a cut. And I'll just paste the Z position up here. Cut Z position up here. And let's see if that sort of helps it. There you go. So it went down a little bit. Goes to the right or left, down, there we go. Now it's going down the correct amount of positions when it goes all the way to the right and when it goes all the way to the left. There we go. So now what we want to do is we want to make it so that if it goes all the way to the bottom, it's going to be game over. So we're going to say, so we have to, now we got to make, keep track of where our bottom position is. And it turns out we could use the bottom position of our enemy, destroy enemy bullet. So I'm going to say, private transform, we'll say bottom marker. So our bottom marker equals game object dot find destroy enemy bullet. Dot transform. So we're going to say if this dot transform dot position dot z, okay, is less than bottom marker dot position dot z, and I forgot my semicolon here. And I don't need a semicolon here. Then we're going to say game over. So how do I call a game over? Well, I got to be able to call my game control. So we need private game control, game control. And you're going to say, I'm just going to copy it from here because I'm lazy. So copy, paste. So game control equals game object dot find game control dot get component game control. So when we get to the bottom, we're going to say game control dot game over. File save. So let's go ahead and see what happens. Okay, so moving down by that many units is really, really slow. So what I'm going to do is I am going to change the down distance to 5. And I'm just going to do it on the first enemy type. So I just want to make sure that our game over gets triggered. Really? Okay. Let's move it 10. 10. 10. Okay. There we go. It's going to go down a little more. Yeah, the suspense. The suspense. Okay, so I'm looking over here. Almost there. That bottom row has to touch. Or it gets past that bottom. There we go. And we got a game over. Because one of the enemies hit the bottom of the screen. And that's it. That is our enemy movements. So let's go ahead and go play our games. So let's go to our player sphere. Let's turn on my sphere collider and let's go ahead and play and shoot some enemies. Oh, actually, before we do that, moving our enemies down 10 units at a time was a little bit too fast. So let's change it back to 1. So we have speed 3, movement 1. And let's go ahead and shoot some enemy. Okay. And there you have it. So if this tutorial helps you out, like, subscribe, and all that other good stuff. And until next time, have fun and keep on creating games.